equations.
Okay.
Equations that have an x squared term in them.
Okay.
And so when you have an equation with where the highest power of x, so that this power of x is 1, this is 2, and you can see this one is 3. So when the highest power of x is 2, you'll get a parabola, which is the name for this shape here.
Correct.
And notice in this equation there's actually 2 zeros. So we could plug in -3 for this equation to equal 0, or we could plug in 1. Either one of those values will make this equation equal 0, and we can just test it, right?
Okay.
So we could do -3 squared plus 2 times -3 minus 3. Oops. And so this is 9, this is -6, and then this is 3. 9 minus 6 minus 3 is 0.
Okay.
And then, or we could try plugging in just 1. 1 squared plus 2 times 1 minus 3. 1 squared is 1, 2 times 1 is 2. Oops. Minus 3. 1 plus 2 is 3. 3 minus 3 just equals 0. So when x squared is the highest x term, meaning there's no x to the 3 or x to the 4s or anything like that in the equation, we'll always have 2 places where there's a 0.
Okay.
And then just to build on that, we're going to zoom in for this one.
I kind of get it now.
Yeah, you're getting it?
Yeah.
Oh, it's hard to
I'll
tell.
probably just record it.
Yeah.
Just
But
record
like
it.
for cube terms, there's 3. There's 3 zeros. So basically the highest power of x you have, that's how many zeros you have. So for this so for your homework problem,
Sure.
where there's a squared in our denominator, we know that there's 2 places where our equation can equal 0. So we should have 2 vertical asymptotes to
Okay.
look for.
Oh, like a little, like it could be like that, right?
So it won't actually look like this on our equation, because this is just to show that there's 2 zeros
Correct.
whenever we have when we have our x squared term. So what that tells us is, since there's that x squared function in our denominator, that there's going to be 2 places in our function that has these vertical asymptotes.
Okay.
That's what it's telling us. And so
Okay.
we just want to figure out what x value those lines are at. And the way we figure it out is we just solve that denominator for 0 and see what those x's are.
Okay. Okay.
Right.